Now let's take a look at a free response question and try to do some plotting of the velocity time graph. So the question says, sketch a velocity time plot for the following motion. Okay, so let's start with motion number one. Okay, let's first draw what's happening there, right? And then we'll try to draw the VT graph. The ball is dropped from certain height and bounces off a hard floor, right? So the ball starts from here at t equal to 0, let's say. It is getting dropped and then it hits the floor, right? Here we'll have a velocity which is maximum, okay? And if we assume the positive direction downward, of course, my negative direction is going to be upward, right? So the velocity is going to start at t equal to 0, where the velocity is going to be 0. And then it will reach a maximum velocity and then bounces back, which means now suddenly there will be a change in direction of the velocity, but the value of this will be same, right? Because the speed just before its impact on the floor is same speed just after the impact, right? So Vmax it is going to hit, and the Vmax it is going to go up, right? But there will be abrupt change in the direction from positive to negative, and then it's going to go up, and then you will again reach a zero velocity, and then the same thing will continue, right? It will come down, again hit with a Vmax, and then again bounces back with the Vmax. Okay, so that's the situation, and we are going to draw a VT graph for that. Okay, these are V and T. So at t equal to 0, the ball starts with a velocity 0, so we are over here. Then gradually, with a constant acceleration g, which means we'll get a slope, something like this, with a constant acceleration, increases the value to a Vmax. So we are going to say this is my Vmax. At this point, the collision will occur, and basically suddenly the velocity will reverse, but with the same magnitude, right? So at this point, we'll have to come down somewhere here, which is minus Vmax, right? So now the ball will start traveling upward. The slope will be again same because the acceleration is same, right? As the acceleration to gravity is same. As you can see, the slope of this is same. And when it reaches the top, basically again hits the 0, okay? Then continues on the same path like that and reaches the Vmax point, okay? So this is a Vmax point. And then again reverses, and then you get a graph which is like this, okay? On the VT graph, we can mark how it will look like. So this is the starting point, right? This is our impact point, right? When it hits the hard floor, at the impact point, we get plus Vmax to the negative Vmax sudden. So that's why I put a dash, dash, dash. And then from Vmax, it goes up. This is our, again, reaches the starting point or top point where the velocity becomes 0, right? And after that starts to come down, then the velocity becomes positive, right? So from when it's going from down to up, basically the direction is negative. That's why we are getting a negative. And then again reaches the top, and this is the impact point. Okay, so that's our VT graph, which looks like this. Now let's look at part B. A cart slides with negligible friction along a horizontal air track. So we have a horizontal track and we have some sort of a cart over here. It's sliding with negligible friction. When the cart hits the end of the air track, it reverses the direction with the same speed it hit it right before. So it is sliding, which means it is moving with a constant velocity, right? And then it hits something and then reverses back with a constant velocity. In fact, assume the time of contact of the cart and the intertrack are negligible, then how the graph looks like, right? It is moving with a constant velocity. Okay. So we are going to assume this side to be positive, okay, and anything moving in this side to be negative, right? So for some time, when the cart is just sliding with negligible friction, right, it's moving with a constant velocity. So we are here. Now it's going to hit the obstruction or wall, and then reverse the velocity, okay? So it's going to go and reverse the velocity, right? So this is minus V with the same magnitude, right? The same height, and it's going to reverse the velocity. So our VT graph is going to look like that. And there's a discontinuity because of the collision, right? It is a discontinuity because of the collision. Okay, so this is our collision point, right? This is our collision point. Let's look at part C. A person jumps from a hovering helicopter. So we have a helicopter here. right? Looks funny like that. He jumps from a hovering helicopter. So helicopter is stationary, he jumps. After a few seconds, she opens a parachute. So she jumps. So let's assume it's jump from rest, right? From jumps from rest, just drops from rest. First, she is going to accelerate, okay? And then she's going to open the parachute. When she opens the parachute, the acceleration decreases, right? Because the parachute is going to become some drag. So might have decreasing acceleration. And then after some time, she will reach terminal velocity, right? Which means that the force of gravity is equal to the force of resistance provided the parachute. So from here, when the parachute opens, right, she gets decreasing velocity, then she achieves terminal velocity or constant velocity. Okay, so this has three parts now. So what we are going to do, we are going to draw the VT graph like that. But before we draw it, we need to provide our signs. For simplicity, we are going to say everything in the downward direction is positive. So she starts from rest, right? Accelerate with constant acceleration like that. Okay, so this is our constant acceleration. Now the parachute opens at this place, right? So this is our speed when the parachute opens. When the parachute opens, her velocity or her acceleration is going to decrease, right? So her acceleration is going to decrease, which means we'll get a slope which is not that steeper, but slightly lower, right? So the acceleration will be less. And then at this point, when the terminal velocity is reached, she will go with the constant velocity, right? So the graph is going to look like that. So from A to B, you have a free fall, right? And then from B to C, you have a falling with a parachute. And from C to D, C has achieved a terminal velocity or uniform velocity, right? So this is how the graph will look like. First steeper acceleration, then less acceleration, and then no acceleration at all with the terminal velocity.